Now let's talk about some applications of constant velocity. This question that I have right here on the screen shows a motion graph of two objects. For convenience sake, we'll call them trains again, that are traveling on parallel tracks, and this shows their position as a function of time on the graph. Question's asking, as you can see on the screen, do A and B ever go the same speed? And if they do, when does that happen? So I want you to think about when you think that's taking place and make sure that you have a rationale for when you think it happens. Think about that. Pause it for a sec. Great pausing, great thinking. And now let's talk about what's happening here. On a position versus time graph, we know that the slope will always give us the information that we need about the velocity. So they both have positive slopes, which means they're both going the same direction, but they also both have different slopes. And if they have different slopes, then they can't possibly have the same velocity. A, which is steeper, must be going faster, and B, which is less steep, must be going slower. Slower. So they never go the exact same speed because they always have different slopes. If you did think that they were going the same speed, then you probably said that it was happening here. And I appreciate that you zoomed in on that particular moment of time because there is something interesting happening there. It's not the same speed because even at those locations, they have different velocities. But what is happening there is they have the same x. They're at the exact same position, which means right there on the position versus time graph is where they cross each other, where A catches up and passes B. So that's that question. Let's move on to our next one. Here I have just like a little story that we're gonna put together. We're gonna figure out what's happening here with these different people. But to set that up, I have to give you guys a stage. And I've got a little drawing up here where we've got school. We're going to say school is the 0 point. That's where the origin of our graph is. Oops, I forgot to give us axes on these graphs. So it's position versus time graph again. So the school is where 0 is, and anything that goes in our negative direction is getting closer to the forest, and anything that is going in the positive direction is going towards the swan's house. So let's think about what Edward, Bella, Jacob, and Renesmee are doing here. I'd love for you guys to pause it right here and record it yourselves. Yeah, go. Okay, unpause. I feel like I stop for a long time for pauses sometimes, and that's kind of dumb because pauses are as long as you want them to be. So talking about what's happening here. Edward, we'll talk about Edward first. He starts at 0, and if he starts at 0, then he's starting at the school. And then we can see that he has a constant velocity that's meant to be a straight line, and he's going in the positive direction. So we'll just say that Edward is running towards the swan's house. Along his way, he must pass Bella because we can see that there's an intersection that happens there. And any intersection means that one object is passing the other. It's a position versus time graph. So let's talk about what Bella's doing. Bella, her position is the same every single second along the way. Does she have constant velocity? Absolutely. Is her constant velocity 0? Yes. Is Bella the worst character who's ever been written in any story ever? Probably. She's just sitting there doing nothing because she's totally uninteresting. So Bella is staying there. Edward went past her because she's so boring. He might as well have continued on with his life. Now let's talk about Jacob. Jacob went the other direction. Jacob, unfortunately, doesn't get to be as exciting because I already did Edward's character and I had to make Jacob different. So Jacob went the opposite direction because they don't agree with each other. Jacob is moving towards the forest, but he's not going as fast. And you can tell that he has a less steep slope. So he's going less fast. And because his slope is negative, unlike Edward's, he's heading in the negative direction. So Jacob's going in the negative direction. And then next we have our last one, the last person we haven't talked about yet, is Renesmee, who has a very unfortunate name. And Renesmee started all the way over at the Swan's house, but she decided she was done with that. She decided to run as fast as she could. She's running faster than Edward, certainly faster than useless Bella, and she even goes right past Jacob because he's kind of a creeper. And she just runs into the forest and she's never seen from again, which I think was a solid life choice. So that's the story that's happening there. And hopefully you didn't get buried in my evisceration of the Twilight series um, while I was talking about motion. Our last one. Do A and B ever go the same speed? This is similar to question 16. So once again, pause it and record what you think. And in particular, when do you think they might be going the exact same speed? So this time they are going the same speed. Somewhere along this area here, they seem to have the same slope. And since slope is always on a position versus time graph, the velocity, since they have parallel slopes, they also are going the same speed. Right here, if we're going through it, it looks like B passes A, and then A eventually speeds up and passes B again. But we have to, one caveat before we finish this video, B was going at a constant velocity. His velocity was actually a constant function. A, I cheated a little bit because he was not going at a constant speed. He was going slow, and then he eventually sped up. So we'll talk about those changes in speed in our next set of videos when we do constant acceleration. But for now, you're done.